But we don't have something of that form. So we want maybe n1 plus n2. We've got a bigger problem here, though, which is that, well, actually, we could go this far at least. Rewrite backwards by h. Now let's apply the constructor. Okay, fine. Now A1 had better evaluate to A eval A1. That should be provable by induction. We hope. That's the way this proof should go. It is not provable by induction because our proof is broken. And here's how it's broken. When we were back here and we did the induction on A, we're saying whatever the sub-expressions are, they all evaluate to n. That n does not vary as we traverse the expression A. So we're going to get an induction hypothesis that's just too weak and is wrong. And we will get stuck. So what we have to do before we do the induction on A is move n below the line. I say revert n here. You can also do it by this generalized dependent n here, which moves n and anything that depends on n below the line, but here they're equivalent. All right, now when we do the induction on A, the induction hypothesis will be a lot stronger. This, with the for all in it, is a more general induction hypothesis. It says, well, for each sub-expression, whatever it happens to evaluate to, and this is good. All right, now, in ordinary mathematics, we don't need to revert n, because ordinary mathematics accepts invalid inductions, because, you know, you get the idea, and you shouldn't use it to prove things that aren't true. Okay, and here's what Vladimir Voevodsky said to me in about 2009. He said, Andrew, you're teaching your undergraduates to do proofs by induction that are more intricate than mathematicians usually trust themselves to get right. Okay? Well, computer scientists can't do inductions more intricate than mathematicians trust themselves to get right unless they have a proof assistant. And we have a proof assistant. Okay, but this is a very common pattern. If you have two variables above the line and you're doing induction on one of them, think about whether you need to generalize by the other. Okay, and once you do that, the proof goes through quite easily. One way to move things below the line is revert, but you can only revert n if there's nothing else above the line that depends on n. So you could revert n and h3, right? Generalized dependent n moves n below the line and drags with it all the hypotheses that depend on n. I prefer revert because I like to notice what hypotheses I'm dragging below the line, but you can do it either way.